All right, word problems and linear systems. Says the sum of Eric and Bob's weights is 9 times the difference of their weights. So I'm going to stop right there. So what we want to find are Eric and Bob's weights, right? Or at least Bob's. So in order to find Bob's, we're going to have to write down some variables. So let's make B equal Bob's weight. That's the thing we really want to know, but we're probably going to have to find Eric's weight along the way. So let's have E equals Eric's weight. We do not know it, but we can represent it with E. Cool, and so we know the sum of those two weights is 9 times the difference of their weights. So the sum of their weights, of course, is just this, B plus E. I'll move that down here. B plus E. And the sum of their weights, that's this down here, is 9 times the difference. So is, tells me equal sign, this is equal to 9 times whatever the difference between their weights is. Well, if the sum is B plus E, then the difference is subtracting. And they do say at the bottom here, Eric weighs less than Bob. So if we were to subtract their weights, we want to do Bob minus Eric so we don't end up with a negative weight. So I'm going to do that. Bob weighs more. So if we take away Eric's weight, we get a positive difference. And that's what's going on there. Cool. It says the positive difference, which again is this, of their weights is also 240 pounds less than the sum. So if you want to think about it like this, the positive difference in their weights, so that's B minus E again because Bob is heavier than Eric, is 240 pounds less than the sum. So here's the sum, B plus E. And of course, this is not true, right? This is saying that they are equal, right? The difference between their weights and the sum of their weights are equal, and that's not true, right? The difference between their weights should be less than the sum, right? If you add them together, you're going to get more than when you subtract them. And that's exactly what they say. Well, how much more is this? Well, this is 240 less than this. So this one's smaller. It's 240 smaller. So you could either add 240 to this side or subtract 240 from this side to make them equal. I'm going to just minus 240 from here. And here are our two equations. From here, we should be able to solve for Bob and Eric's weight. If there's a quick way to get Bob's weight, I'll do it. But in this case, it looks like I think I'm going to have to find Eric's first. In fact, I noticed something down here. I've got B minus E and B plus E. So when I get my B's together, right, I'm going to have to subtract B from one side. It's going to eliminate this other B. That's going to be convenient. And of course, if I get my E's together, I'll add that E over. So I'll get 2 E's. So that's exactly what I'm going to do. I'm going to take this bottom equation, and I'm going to add E to both sides and subtract B. And when I do that, I do it to like terms. So this is gone, that becomes 0. And this is gone, that becomes 0. And of course, 0 minus 0 is just 0. Don't forget that you need something on this left side. You can't just have nothing. So 0 is what we have. This, of course, also becomes 0. Which is just kind of a coincidence, right? And then we get 2 E's over here. 2 times E is the same thing as E plus E. So I know whatever E is, when I double it and subtract 240, well, I get 240, right? Because that's why I get 0 here. If you don't see that, add 240 to both sides and you will. So at this point, I think what I'm going to do is just divide, or think in my head about what times 2 gets 240, right? Well, E is going to be 120. So I found Eric's weight, and I can use that to help me figure out what Bob's weight is. So now I know Eric is 120. I can plug that anywhere into the original equations and solve. But I think what I'll do is I'll plug it in to this top equation, right? Because this bottom equation, B goes away. Even if I plug in E, it'll still go away. It won't be very useful, right? So plugging in here is going to be a better go. So I'll do that over here. B plus whatever E is. And we said E is 120. And then we're timesing by 9 times B minus 120. Let's see if I can fit that in there. Yeah. So E is, again, 120. We figured that out. So here's our new top equation with E's value plugged in. Oh, I put these markers on the wrong cap. That's why. There we go. So from here, since I only have one variable, I can get them together and I can solve. Now, in order to get those b's together, I first have to understand what this really is. This isn't a single b. This is actually 9 b's, right? Because we're timesing that whole thing by 9. So what we'll have is b plus 120 equals 9 b's minus whatever 9 times 120 is. I'm going to just write that. You could totally distribute that and figure out what 9 times 120 is, but I notice something's going to happen here, and I'm going to do a little shortcut. So if you want to write that as 900 plus 180 and go ahead and do that, that's fine. I'm going to get my b's together by subtracting. So if I subtract b from both sides, this becomes 0. That's why I did it. And I get 120 equals 8b minus 9 times 120. So when I get my regular numbers together, I can add this entire term over, and I think you'll see that this becomes 0. That's why I did it. But over here, I have one 120, right? Just one of them, right? And I've got 9 of them here. So what I end up with is 10 120s, which is actually pretty easy to do in your head. That's 1, 2, 0, 0. And of course, that equals 8b. So now I have to think, what times b gets you 12 with 2 zeros on the end? Well, it's definitely going to be some kind of weird number, right? If b is 100, that gets me 800. So it's got to be more than 100. And we know Bob weighs more than Eric, right? So it's definitely going to be more than 100. And it's going to be more than 120. So if 100 gets me 800, and I'm 400 away, well, I need 50 more, right? 8 times 100 gets me 800. And I need another 400 to get a total of 1200. So I think 8 times 50 is what I need. So Bob must weigh 150. And we can check those answers in the original problem. And if we do that, we'll get the right answer. Looks like 150 minus 120 is 30, right? And this is adding them together and subtracting 240. Well, you get 270, so minus 240 is 30, so that works for this. Here we get 270, and if we take 30, which is what the difference is between these, and times it by 9, we also get 270. So yep, this is the solution for Bob and Eric's weight. I think for this one, the hardest thing was the words, right? The sum and the difference, 9 times the difference. When people said they said they were confused by the positive difference, that makes sense that they were, because it's weird that they throw that in front. But it's just because if you subtract Eric and do Eric minus Bob, you'll get a negative difference, right? So it's important to think about which one is heavier. All right, 5, 4, 4. Green balls and red balls. So it says 5 green balls and 2 red balls together weigh 10 pounds. So I'm going to write that down. So G, and I guess I should do that in green. G is the weight of 1 green ball. That's what I'm going to define that as. Because it wants to know what's the weight of 8 red and 8 green together. So I'm going to need to know the weight of a green ball. And I'm going to need to know the weight of 1 red ball. So using these variables, I can work with these unknown weights. And I can write down 5 green balls and 2 red balls together makes 10 pounds. So if I take a weight of 1 green ball and I times it by 5, that'll give me the weight of 5 green balls. And if I take the weight of a single red ball and I times it by 2, that'll get me the weight of 2 red balls. Which, of course, 5 green and 2 red, according to them, adds up to 10 in total, 10 pounds total. So weight of 5 green plus weight of 2 red is going to get us the total weight. That makes sense. They also tell us that 1 green ball and 4 red balls weigh 7 pounds together. So 1 green ball, so just G, right? Or 1G if you want. And 4 red balls gets you 7 pounds. So the question is, 8 red and 8 green. How much will that weigh? Whoops, did the wrong one there. 8 red and 8 green. Let's make those 8s black. I want to know how much that weighs. Well, there's a couple ways to do this. One, you can do it kind of like we did the last problem, right? Get a variable on its own, plug it into the other, do substitution, right? However, notice that we want to find not the individual weights. We want to really find what 8 of them and 8 of them is. Well, this is the exact same thing as 8 times the weight of a red and a green combined. Right, and that makes sense, right? If we knew the individual weights, we could add them up and then times them by 8. That would be the weight of 8 of them each, right? So really all I need to know is this, right? What's the sum of a red and a green? And if you look closely, over here, if I were to add these together, this is not elimination because nothing will go away. But if I add a green and 4 reds to this side, and of course to keep it balanced, I'd have to add their total weight to this side, 7. I end up with 6 green and 6 reds equals 17. And this is helpful because if I factor out a 6, if I divide by 6 to everything, I'll get what I want, just a pair of red and green, right? And then I can take that and times it by 8 and we win. So that's what I'm going to do. I'm actually going to divide everything by 6. And what I'll end up with is 1 green plus 1 red equals 17 over 6. So basically we know that a single green combined with a single red will get us 17/6 of a pound. So if you want to think about that for a second, 17/6 is almost 3 pounds, right? If it was 18 over 6, it'd be exactly 3 pounds. So we're going to have some fractional answers. So this is the weight of 2 combined, right? 1 of each. So if I want to know what 8 of them are, right? 8 red and 8 green, all I have to do is times this by 8. So if I take this, and I guess I'll do it in pink, and I times that whole thing by 8, what we'll get is the answer to our question, right? Because this will represent 8 green and 8 red. So what is 17 over 6 times 8? Well, I don't really want to do 17 times 8. I could if I had to. But instead, I'll actually divide by 6 first. Now, 6 and 8 don't divide out nicely, but I can factor that 6 to 2 times 3, and I can factor that 8 to 2 times 4, and you'll notice that these 2's divide out, right? See, it says divide by 2 and divide by 3. We can divide those 2's into 1's. And now, all I have to multiply by is 17 times 1 times 4. So that's a little bit easier. Well, 17 times 1 is just 17. Timesing by 4, we get 40 and 28. So that's 68. And then we still need to divide by 1 times 3, which of course is 3. 3 does not go into 68 nicely because it goes into 66 and 60. So this is our weight for our 8 combined, 68 over 3 pounds, which you'll notice is just a little bit more than 22 pounds, right? 22 and 2/3 pounds is what that will be. So that's a pretty novel solution, right? Seeing that in order to get this, we just need a g plus an r. And one way to get that is to combine these two equations by adding. But of course, you could have solved this by getting g on its own, subtracting that over and plugging it in, doing substitution. So let's take a look at 545. This is the last one in this video. It says, at a certain time, Janice notices that her digital watch reads a minute. So that's a variable, right? A certain amount of minutes after 2 o'clock. 15 minutes later, it reads b minutes after 3 o'clock. So a different number, right? And now it's after 3. She's amused to note that a is 6 times b. So I'm going to write that down. So a is the number of minutes after 2 o'clock, and it is 6 times whatever b is. Okay? So again, let's label those variables. A is minutes past 2, and b is minutes past 3. So we want to know what time was it when she looked at her watch for the second time. So in other words, we want to know 3 and then B. I'll write it like that, right? So here's 3, and then B is the number of minutes past it. That's what we want to know. All right, well, I've only got one equation. I need another equation. So if I go back to the top, you'll notice it says that her digital watch reads A minutes after 2 o'clock. So how can I represent that, the original time, A minutes after 2? Well, I can write it like this, I suppose. So there's A minutes after 2. Then it says 15 minutes after this. Okay, so if I add 15 minutes to that, then it reads B minutes after 3 o'clock. So now it's 3B, the thing we want to know, right? Well, we know that whatever this time is here, after 15 minutes it crosses into the 3 o'clock range. So one way to think about this is think about what's the latest it could be. Well, it could be 2:59, and then we add 15. That'll put us into the 3 o'clock range. And of course, the smallest A can be is 2:45, right? So if that was 45 minutes after, if we add 15, we'd barely squeak in exactly at 3 o'clock. So A is going to be between 45 and 59. So I'm just going to write that down just so I can check my answers. A is going to be between 45 and 59. So I think I need a new way to represent what's going on here, right? This is a little weird with the clock colon there. I think what we want is the number of minutes after 2 is A, and if we add 15 to it, we're going to get a certain amount of minutes after 3. Well, if you think about it, between 2 and 3, 60 minutes have gone by. So 60 minutes later plus B is going to be what time this is, right? 60 minutes after 2. So here's our equation, here, and together we should be able to solve for what's going on here. So I'm going to rearrange this bottom equation real quick, just get A and B on the same side. A minus B equals, and then I'll subtract 15 from both sides to get 45. And then I have this other equation, A equals 6B. So from here it looks like substitution would be a good idea, right? A is 6B. So if I substitute that into the other equation, I end up with this. And then I can combine my b's to get 5b equals 45. So it looks like b has to be 9. So what time is it going to be? Well, it's going to be 3:09 when she looks at her watch again. Which means if you want to figure out A, right, 15 minutes before that is going to be 2:54. Because it's 6 minutes and then 15 more gets you to 9. So that's it for that one. I think representing this is what the hard part is. I think if you think about it, 60 minutes later gets you 3 o'clock versus 2 o'clock is like at 0, right? That can help you out. So hopefully this setup makes a little bit more sense. And of course our answer, knowing like what it's between, can help us guess and check even if we're lost. And it can also help us check our answers. All right, so that's it for the word problem.